Hi everyone, I'm Ellie. I'm a PhD student here at SAMS and my project's about biorefinery of microalgae, but today I'm going to be talking about just one of my species, Chromochloris zofingiensis, and the scale up into the ARIES PBRs. So first of all, what is biorefinery? We define biorefinery as a separation of multiple products from one form of biomass, which in this case is microalgae. And the reason behind this is to increase the value of the biomass whilst reducing waste, and then in turn you can improve the economics of the process. So there's a lot of different there's a lot of different stages to a biorefinery process. You've got the upstream process, which includes species and strain selection, followed by optimizing the biomass and then accumulating the biomass. And then you've got the downstream process, which includes harvesting, cell disruption, product separation, and then further purification if necessary. So Chromochloris zofingiensis is a chlorophyte, which has the potential to compete with Haematococcus for astaxanthin production. And this is because Chromochloris can accumulate really high biomass concentrations, even though there's less astaxanthin per cell. Therefore, this gives reason for using a biorefinery approach for this species. So the target products from this are carotenoids, which includes the astaxanthin, but also beta-carotene and lutein too, lipids, mainly in the form of tags, starch and proteins as well. So to do this, to accumulate these products within the cells, you need to do a two-stage process. So the first part is this green phase on the left, where you want to increase the biomass in terms of the number of cells. And then you need to either change the growth mode or apply a stress to the culture to change the color of the culture from green to red. So carotenoids are the most high value compound from this product, from this species. So I did a trial comparing different growth modes. So I had phototrophy with and without nitrogen, mixotrophy and heterotrophy. And I compared the total carotenoids produced from these. So mixotrophy and heterotrophy had very similar concentrations, but when you look at the extract across a wave scan, you can see from these two diagrams on the right that basically the chlorophyll's degraded more in the mixotrophic sample, which is why it appears more orange, as you can see on the third picture along. So for this reason, we chose mixotrophy to scale up into the ARIES PBRs. So to do this, I grew 3 carboys, which were 10 litres each for 3 weeks phototrophically, and then we inoculated them into the ARIES PBRs. So we grew them phototrophically again for 15 days, and then we used the membranology membrane to concentrate the biomass and wash it to remove any of the excess nutrients. And then we re-inoculated it with fresh media that contained glucose and didn't have any nitrogen in it. And we also increased the light intensity and changed the routine from 16:8 to 24:0, so they had continuous lighting. Here are some of the results that we obtained. So the biomass increased from, on average, 0.6 grams per litre up to 5.1 grams per litre across the 8 days, and the OD increased as well. In the small scale experiment, it was only over 5 days, but this time it was over 8 days because we were monitoring the wave scan every day to make sure that the chlorophyll had fully reduced to ensure that the carotenoids would be the maximum. The graph on the bottom left shows the carotenoids from each PBR, and the average here was 14.5 milligrams per litre, which was a lot higher than in the small scale experiment, which was only 6.3 milligrams per litre. But the biomass concentration was so much higher in the PBRs that this meant the actual amount of carotenoids per cell was lower. And you could tell this under the microscope as well, because the cells only appeared like a yellowy colour, even though the whole PBR looked orange. Whereas in the small scale experiment, the cells looked a bright orange colour under the microscope. So after the 8 days, we harvested again using the membranology membranology membrane system. And this was really efficient. You could harvest each PBR, which is around 65 litres, in 47 minutes. So that was really efficient. And then we used the centrifuge in the biolab to concentrate down to a total of 1.5 litres from each PBR. So with this biomass, I've been looking into the further stages of biorefinery. This is a picture of before and after bead beating. So the cells of this species are fairly difficult to break, but I'm going to be trying a lot of different variables and parameters to optimize this process. But you can see in this picture here, well, I think you can, the cell walls are visible and the small dots are starch granules from within the cells. I'm also going to be looking into centrifugation, membrane filtration, and solvent extraction to fractionate the products further. So thanks for listening. I have a video on algal pigments that was part of the BPS competition, if you want to check that out. And here are some references if you want to know more about the species or biorefinery. And thanks to my supervisors, and special thanks to Ryan and Karen for helping me set up the PBRs.